Alright, we're going to take a look at creating assembly drawings in Inventor. They are a little different if you're used to anything like AutoCAD, which you just take a regular drawing. Here, when we create a drawing, it is a specific part. Like when we drew parts, we'd use the part. When we draw assemblies, we're going to use assembly. Okay, the different methods, the bottom-up approach. Okay, the first step in the bottom-up assembly modeling approach is to create the individual parts. The parts are then pulled together into an assembly. This approach is typically used for smaller projects with very few team members. This is how I do 90% of my assemblies, and this is what we'll look at today. The top-down approach. The first step in the top-down modeling approach is to create the assembly model of the project and do it completely backwards. Initially, the individual parts are represented by names or symbols. The details of the individual parts are added as the project gets further along. This is used for really large projects. Middle out approach kind of uses a mixture of both. Okay, this type of assembly model is usually constructed with most of the parts already created, and additional parts are designed and created using the assembly for the construction information. Okay, it's very flexible for creating assembly models. Okay, we're going to look at degrees of freedom. Degrees of freedom, each component that we put in an assembly drawing has 6 degrees of freedom by default, okay, called DOFs. Okay, there's moving along the X, Y, and Z axis, that's translational freedom, plus rotation around the X, Y, Z, that's rotational. So there is 8 of them, or 6 of them. Okay, this one is not constrained. You'll see that there's the translational, X, Y, and Z, and then the rotational on each one. Okay, so I'm going to take a look at, got to go all the way back to here. Whoops, went to the wrong one. And I'm going to go to Inventor, which should have went there. And I'm going to go to New. Okay, and I'm going to create an assembly. Okay, so here's a standard inch assembly under assemblies. Okay, and you'll see this is a little different than our regular member. Here we take and we place, so if we're doing from the top down, we're going to place the parts that we have. So I'm going to pick place. Okay, and I'm going to take, and I'm going to find somewhere, okay, this bearing right here. Okay, now it's going to slap there. You'll see the X, Y, and Z, and I'm going to go over here and I'm going to make it the isometric view so I can see where it is. Now if I just place it there, okay, I can place as many as I want, keep hitting my left mouse button, but I'm going to right click and pick OK, and that way I have here. Now if I go up here to view, you'll see degrees of freedom. Okay, and that shows me how many degrees of freedom I have. Okay, so this shows it, which means I can move it up and down, and I can also rotate them around. Okay, normally the first one that we do is pinned. Okay, so I right click on here and I put grounded. Okay, here you'll see that when I highlight that little pin there, and you'll see that now I have no degrees of freedom. That does not move. I usually do this with my biggest part or my base, and I'll put the other parts in individually. Okay, now once I've grounded this, now I'll put any parts that I want to put there, and I'll make sure I'm on assemble. I'll go to place. Okay, and on there I have a piece that goes on top of that called a collar. Now notice I can put it wherever I want, and I'm just going to put it right there. Okay, again, there are my degrees of freedom. Now if I grounded that, I wouldn't be able to move it. Okay, as I attach this part to this part, the degrees of freedoms will go away. Okay, until we have no degrees of freedom, and then it is completely constrained. Okay. All right, the different types of constraints, we have a mate constraint. These are under constraints. We have a mate, we have an angle, we have a tangent, we have symmetry, and we have an insert. Okay, the mate constraint puts components face to face or adjacent to one another with faces. Okay, they can be flush, removes 1 degree of linear translation and 2 degrees of angular translation. Selected surface points in opposite directions can be offset by a distance. Okay, so if we take a look here, now I'm going to go up to constrain. Okay, under constrain, you'll see place constraints. Here we have our types. We have mate, angle, tangent, insert, symmetry. Okay, so the first one is mate. I'm going to mate this part with that part. Now I want to line up the center of this with the center of this one. Okay, so I stay in mate, and I'm going to pick mate right here. Okay, now I can pick a surface like right there. Okay, but if I pick any as cylindrical, you'll see it picks the axis there. So I'll pick that axis and that axis there, and I'll put them together. Okay, now where I put it doesn't really matter. I'm going to pick OK. Now I can take that part that I just put in there, if I can get a hold of it. Okay, and notice that I can move it. Notice the degrees of freedom. There's only 1 degree of freedom now. Okay, it can rotate. I can move it up and down. I can actually go through the part. Okay, so what I want to do is constrain again, and I want to constrain the surface underneath here to this top surface right here. Okay, now what I can do is I can rotate everything like that, and I can pick them. Okay, so I can go like this. Now I can see this part here, and I'll go to constrain, and I'll pick mate again, and I'll pick this surface right here, which is going to sit flat against this surface right here. Okay, once I do that, notice the only degree of freedom now I have is the rotation. Okay, so now if I try to move this, I can't move it. I can rotate it around. In this case, it really doesn't matter if I rotate it around, okay, because it is constrained on top of that. Okay, I can take and I can make an angle. Creates an angular assembly constraint between 2 part subassemblies or assemblies. Select the surface points in the direction specified by the angle. So here, for example, okay, I took that same plate and I put a block here, and I have the plane going through the center and the plane going through the center here. Now I can make sure that's 90 degrees there by putting an angle right here of 90 degrees. Okay, now it will be constrained so it's at that 90 degrees. Tangent, align selected faces, planes, cylinders, spheres, and cones to contact at a point of tangency. The tangent may be inside or outside of a curve depending on the selection of the direction of the surface normal. A tangent constraint removes 1 degree of translational freedom. So with the tangent, you have to pick at least one curved surface. So I could take, for example, and make a tangent between this point and that face right there. Flush makes 2 planes coplanar with their faces aligned in the same direction. Selected surfaces point in the same direction and are offset by a specified distance. Flush constraint aligns components adjacent to one another with faces flush and positions selected faces, curves, or points so that they are aligned. Well, we'll see that. Note the flush constraint is listed as a selectable option under the mate constraint. Okay, so for example, I could take this part here and make this edge flush with that edge right there. Insert aligns 2 circles including their center of axis and plane. So like the one that I did before, I could just use the insert command and insert those inside of them. Okay, so again, here's taking that and did the same thing I did, except using insert, and then I would pick this angle here. So let me show you that. Okay, so let me go into Inventor and let me undo that. Somewhere, there we go. Now what I'm going to do is I'm going to go to constrain, and here I'm going to pick insert. Okay, I'm going to swing this guy around, and I want to insert this one right here. Notice it picks that surface and it picks that center point. So I'll pick there, and I'm going to insert that into this one on that edge and that surface. Okay, again, notice I pick OK. The only degree of freedom I have is the rotational. So we're back to where we were before. Symmetry. Constant positions two objects symmetrically according to a plane or planar face. Okay, so we can take something like this and we can make those symmetrical to each other. So if I move one, the other one moves the same. We're going to look at a demo of that in a couple minutes. Now, besides constraints, there are joints. Now, joints do the same thing as constraints, except they're a little different. They were added to Inventor maybe a couple years ago. There's advantages to joints over constraints, from constraints over to joints, and that'll take time to figure out, and hopefully when I do the demos you can see some of the differences. Now the types of it, there's automatic. It'll automatically try to guess what kind of joint you want. Okay, the different types of joints, there's rotational, cylindrical, ball, and rigid. Okay, the rotation is picked if two selected objects are circular. We'll think, okay, you want a rotational. If there are points on a cylinder, use cylindrical. If you have 2 points on a sphere, do a ball. And rigid is for everything else. Okay, again, rigid. Positions a component, removes all degrees of freedom. Okay, use this if you don't want them to move. It's like welds and bolts and whatever you need. Rotational, positions a component, specifies one rotational degree of freedom. Supports user specified limits, what we'll look at. Hinges, rotating levers are examples of rotational. Slider, positions a component, specifies one translational degree of freedom. Okay, it removes all the rotational but allows you one direction that you can slide in. Cylindrical specifies one translational and one rotational. Okay, a shaft and a hole is an example of cylindrical, where it can go linearly and rotationally. Planar, position component specifies two translation and one rotational degree of freedom. Ball is like a ball joint. I've never used this. Alright, we're going to take a look at some demos to look at some of these different ones. Let's take a look at this assembly here, where we're going to take this top here, put it on here. I'm going to take this screw here and attach the two together. Now I'm going to do this twice, and I want to show you the difference between using the constrain and using joint. I'm going to go constrain, and I'm going to put this piece on top of this piece. Now there's a bunch of different ways I can do this. Okay, but what I'm going to do is I'm going to go here to free rotate, which allows me to rotate one without the other. So I'm going to go to free rotate, and I pick this guy, and I'll lift it up this way so I can see underneath. Now I'm going to constrain this surface here to this surface here. I'm going to go to constrain. I can zoom up on it, and I'm going to pick that surface and that surface. Okay, so now those two are constrained with each other, but notice I can still move it around. Okay, I can do it a bunch of different ways. I could constrain this hole here with that hole there, and then that hole there with that hole there. Or I can take and make it flush. Okay, so let's do one of each. Let's take and constrain the center of this to the center of that. So I'm going to go zoom up. If I touch anywhere on that circle, see that I have an axis line there. And I'm going to line up that one, and there's the second one. And I'm going to line that up there. And pick OK. Now notice it can revolve around that. Now I could line up this hole with this hole, or I could go here and I can make this surface flush with that surface. Pick flush and flush. Okay, now that lid is tight there. I'm trying to move it. You can't see that. Okay, this first one, you'll see that little icon, it's pinned there. Okay, now I need to put the screws in the hole, and again, there's two different ways I can do it. I can go to constrain. Again, I can pick the center of this and mate it with the center of this one. Okay, now notice it's right in the center, but I can move it up and down. Okay, so I can take and do a free rotate this guy around, and I can constrain this surface to that surface there. Okay, so it is constrained. Now notice I can still revolve that around. That doesn't matter right now, but we could fix that if we wanted to. Okay, but I don't really care about that. Alright, now the second way I can do it is I can use the insert command. So I'm going to go and I'm going to free rotate this guy again so I can see up here. And I'm going to join this circle to that circle, or insert this into there. I'm going to go to constraint, and here I have the insert command, and I pick that circle right there and this circle right here. Okay, again, that's a little easier. It can't move up and down, okay, but it can rotate. Alright, so there I have my assembly. Now I'm just going to undo everything back to the beginning. Of course, it's going to do everything I did. Okay, and I'm going to leave it like this. Okay, so now up here, if you look under relationships, that shows you any constraints that we have. Alright, now I'm going to pick join this time. Okay, now what I'm going to do is I'm going to make this rigid against here. Now if I take and pick this point right there where they come together and align it with that point right there where they come together and make it rigid, that will do my... Alright, so I'm going to go up here to joint this time. Now again, I want this to be rigid, so I'm going to pick rigid right here. I'll move this way out of the way. Now again, it's hard to see. Zoom up on stuff. Okay, and I want that point. See where you get the little point there and the circle? So that's what I want, that point there. And I'm going to constrain it with that point. Now notice it'll flip around. Make sure it's this surface, so it's flat that way. And pick OK. And in one step, I've joined those together. Again, I can go to joint. I can make it rigid. And I can pick this surface here of the screw, put it there. Now sometimes it might come up like this. Okay, this right here, we'll flip it around for us. I can pick apply, pick again that surface to that one, pick OK, and now they won't rotate, they won't move. There is my assembly. Here we have an assembly. This piece goes on top here, the screws go through here, and the nuts go onto the screws. Alright, again, I can use the joint command. I'm going to free rotate this guy around this way. Actually, let's not. Let's leave it this way. Okay, I'm going to go to joint, and I'm going to take this face right here and that center point right there. And I'm going to constrain that with this surface right here and that point. Notice we don't want that. We don't want that. We want this surface and that point. Okay. Now, notice it put it the wrong way. I can take and flip this around. and flip it around there. Okay, notice those two. I inverted the alignment and I flipped the component. Okay, and I'll pick OK. Alright, now I'll take and I'll join. Again, don't be afraid to zoom up, and I'm going to pick that point right there. That's going to go on this guy right here. Pick apply. I want this one here, which will be that one there, and constrain it here and pick OK. Now I need to put the nuts on under here. I'm going to swing this around this way. Okay, now I'm just going to take this surface and put it right on there. Now it doesn't matter because the nut is symmetrical, so it doesn't matter whether I pick this bottom surface or the top. I'm going to go to joint. Okay, and I'm going to make these rigid. I'm going to take this surface right here on that surface there. Now again, notice it's going into the part. Take right here and flip the component. Now it's flicking outside, or it's sticking outside. Okay, take this one here, put it on that guy, flip it around, pick OK. Now we have our assembly. Okay, everything is constrained. Caster assembly, we have a wheel that's got to go on this axle. I've already put the axle in there. Okay, just constrained it right along there. Now, if we take and use a constrain command, we could take the center of here, put it on the center of there, and then pick OK. Now the problem with that is if I go here to the side view, okay, it can go anywhere there. Okay, so what I'd have to do is I would have to figure out the distance from here and here on the bracket, subtract it from here and here on the wheel, and then when I did that constraint, I would take here and offset it that distance. That's a lot of work. I don't want to do that. So what I'm going to do, I'm going to go up to relationships, okay, and actually I'm going to go to wheel, see which one I just did, and I'm going to get that mate and delete it. Okay, and move it out here. Now using the joint command, I have a really nice feature, and I'm going to go to joint, and I want that wheel to be able to rotate, so I'm going to pick rotational. Now if I just come anywhere on the screen here and right click, you'll see here that I can do between two faces. Okay, and I want to pick this face, swing it around, and this face right here. Okay, notice I get the little lip there where it's the center of that one or the center of that one, but if I click there, it's doing the center between the two of those. So right there. Now I want to put it on the center between this one and this one. I can do the same thing. Just bring it off here, right click, between two faces. I want this face. Swing it around to that face. Now I'll get all kinds of clips here. I want it down here at this hole, and I want it in the center there. Okay, if I hold the control button down, I can move that and it will pick where I want it, but I can just eyeball it until I get the one right in the center of that axle right there. Okay, and you'll see that it rotates. I'll pick OK. Okay, now it's hard to see where there's nothing there, but that wheel can rotate. If I look at the right side view, the right side view, you'll see that it is perfectly centered there. I'm going to take a look at the slider command, which is up here with a slider joint, which is right here, and that allows things to slide. Okay, so here I have a little bolt and I want to fit it right into that slot, and I want it to slide back and forth between these 2 points. Alright, so I'm going to go into joint. Again, I'm going to make it into a slider. Let's move out of the way, and I want to pick this point right here. I'm going to shift this around. I want that center right there to line up with that center right there. Now, when I do that, you see there's an automatic play here, and it slides in the way that it thinks I want it. Now, unfortunately, that's not the way I want it. Okay, so what I can do is I can align this piece with this piece. So if I say align, I can pick this surface right here and align it with that surface. Now you'll see that my arrow has changed. If I do the automatic play now it slides in this position here. Okay, right here is where I want it because that's where I want the start point. I go to limits, okay, and I'll start at 0, and I want to end. Now I know the distance between this center and that center is 1 inch. Okay, if I didn't know that, I could look at the drawing and figure out what it is. Okay, and I can put this to 1. Okay, you'll see it gives me the blue line there, so that's how far it's going to move. If I put current here, change that to 1, that looks probably about right. Put that back to there, pick 0, pick OK. Now again, since we only have a degree of freedom sliding this way, I can't slide it that way or move it up and down. Okay, and since I put the limit on sliding from here to there, okay, it will slide back and forth that way. Now I can animate that. If I go in here to slider and I pick drive, okay, notice I have a start and an end. The start is 0, the end is 1 in this case. If I click on this play, notice it'll go between there and there. If I go here and it's going 1 inch, but I make this 0.25, make this 1/4 of an inch, and it's going to move each time, and I play it, see it moves a little bit better than that. Let's make it 0.125. You'll see it sliding. If I make it 0.0625, and I'm just guessing these numbers, and now I play it, you can see it moving, sliding back and forth. Again, I can make this as small as I want to, make it a 32nd, and there you can see it sliding around. Okay, I can also take here and record that in case I wanted to show that at some time. Alright, so that is the slider option of the joint command. Okay, this one we have a couple of pieces here. They're going to slide along this base here, but I also want to make sure that the distance between these two is always the same. Okay, if this one moves this way, this one will stay the same distance away. Alright, so I'm going to use the slider. So I'm going to go into joint. I'm going to go to slider. Okay, and I'm going to go turn this guy around here, and I'm going to pick this surface right here, right there. I'm going to put it right on the center right there. Now it's sliding the wrong way. Okay, I don't know how it knows, but it usually makes it the wrong one. So I'm going to align this surface here, okay, with this surface down here. And I'm going to pick OK. So now this guy can slide along there. Okay, it can't move sideways or up and down. Okay, I'll take this guy and do the same thing. I'll go to free rotate. I rotate this guy around here. Join again. I'm going to pick slider, and I'm going to pick that surface there again, that surface right there. Again, don't know how it knows, but it's making it go the wrong way, so I'm going to align it from that surface and line it up with this surface way over here. That one right there, so it's pointing in the right direction. Okay, So they can move, but they're independent of each other. I want, if I move this one, this distance will always be the same. Okay, so to do that, I'm going to use one of our planes. Okay, I have a plane going through the center here of the part, right there. I'm going to right click on it and I'm going to make it visible. Okay, now what I'm going to do is I'm going to use a constraint. I'm going to go to a constraint, and right here I have symmetry. Okay, and I'm going to say this surface and this surface will always be symmetrical to that plane. Okay, and I'm going to pick OK. I'm going to turn that plane off because I don't need to see it anymore. Turn off visibility. Now these two will always be a specific distance apart. Now they can go like this and go through each other. Okay, I could take each part, this one here, slide bearing 1, this one here, slide bearing 2. I can highlight them, right click, put them into a contact set, go up here to annotate, whoops, I'm sorry, go here to inspect, turn on my contact solver, and there they will never go through each other. Okay, so that's using the slider and symmetrical. Okay, we're going to take a look at this piece here, this assembly here. It's a slide bolt. We're going to have this guy sitting over here. We'll have this slide in the middle here, where this little tang up here will go from here to here and then lock down. Alright, so the first thing I'm going to do is I'm going to line these two up. Okay, so I'm going to swing it so I can see underneath, and I'm going to make this surface and this surface flush with each other. So I'm going to go into constraint, pick flush, and I want this surface and that surface to be flush with each other. I'm going to hit apply. Now I also want this edge and that edge to be flush with each other. I'm going to pick that edge and that edge, and I'll pick apply. Now what I want to do is I want to put this distance from here to here, which is 100 thousandths. So I'm going to go to mate, and I'm going to pick this surface and that surface, which puts them there, and I'm going to put 0.1, so that'll put the distance that I want there. Remember, when you're constraining these, always pick the one that you want to move first. If I try to move this one over here, okay, it won't move because it's pinned. Okay, so I'm going to pick OK. Alright, now what I'm going to do is I'm going to take this guy and I'm going to put it inside here. Now, I want this to move into two directions. I want to move it linearly this way and angularly or rotational this way. Okay, so I want to use the joint command, and what I want to use is I want to use cylindrical. Okay, because cylindrical allows it to have linear movement and angular movement. Now I'm going to take and I'm going to pick this big hole right there and line it up with that guy right there. Okay, and you'll see that it moves around. You can see it moves in all the directions that we want. Okay, and I'm going to pick limits. Now I want to be able to move it linearly this way. So I'm going to go to start. Now I'm going to put this on isometric so I can see what I'm doing. Okay, and right now this is my 0 point, which should line up with that dimension from there to there being right on that edge. Okay, now I'm going to make the end is going to be, and let me find the number that I'm going to put there, is 0.92. Whoops. 0.92. Okay, and you'll see this is how far it's going to move. Now if I take and make my current position 0.92, okay, it looks like that should be about right. You'll see where it moved, and I'll put this at 0. Okay, and then I'm going to put my angular, and I'm going to start at 0, and I'm going to end at 90 degrees. Okay, again, I'll put my current to 90. Okay, and that looks about where I want it. I'll change my current back to 0. So again, I made it so it can rotate from 0, which is where it's at now, down to 90, and from 0 in this direction 0.92, and I'm going to pick OK. Try out our bolt, see how it works. Okay, I can move it that way, and it goes right from there. You'll see one of the problems to there. I can also come here, and I can slide over to here. But you'll see I can also slide through the part. Okay, now I obviously do not want that to happen. So what I can do is, Inventor has something called a contact set, where I can take this solid and make it a contact set with this solid, and it will treat them as a solid. Okay, I'm going to take this part, which is part 1. I'm going to go over here, right click, and I'm going to make that a contact set. And go to my bolt, which is part 2. Right click, I'm going to make it a contact set. Okay, now what I have to do is turn the contact set on. For some reason that's under inspect, and I want to make sure that it says activate contact solver there. Alright, now I can move it, and it moves only where I want it and locks it in that position. Okay, so now we have our assembly here. Okay, and we have constrained it. If I try to move this, it will not move in this direction. Okay, I can take a look at what it looks like here. I can rotate it in this direction back to there. Okay, that is the slide bolt. Okay, let's take a look at something like this, where we have this pin going through this hole here, and then we have this handle sitting in the middle of the pin, and it can go straight down and up to here. Alright, so I'm going to go to join. I'm going to take this guy here, and I'm going to do the outside to that surface right there. Okay, because that's the way it was designed, so that's flush there. Now notice it says rotational. I don't want that to rotate. I want that to be rigid. So I'll pick rigid, and I'll pick apply. Now I want to put the center of this in the center of that pin. I'll go here, and there's the center right there. Go to the pin. There's the center of that. Okay, now it pick rigid, but I want that to be rotational. Okay, now notice though, it goes all the way around. Okay, I don't want it to go beyond this point and beyond the point at the bottom, so I go to limits. Okay, and I put my angular. Right now it's at 0. Okay, and I pick start. Now if I start at 0, it's going to start here, and I could go up to 90. Okay, but I'm going to make this negative 90, so it starts down the bottom and goes up to 90 at the top. Okay, and I'm going to pick OK. Now if I take this, I can't go past there, and I can't, it's kind of hard to do, I can't go past there either. Okay, so it goes from 90 to 90. If I take a look at the front view here, okay, notice I can go from here to here. Alright, so that is using a rotation with some limits on it. Alright, here we have a piece here. This part here is grounded. Okay, the bushing is going to go and sit along this face here. This shaft here is going to go into the bushing. This piece here is going to go onto the shaft. The shaft also has a groove, and you'll see a little groove here in this handle. And here we're going to have a keyway that's going to lock that in. Okay, this guy here is going to get attached to that hole, and then the little ball here is going to get attached to this thread here. Alright, so Again, we're going to use probably a little both here. So I'm going to start off with the joint. Okay, and I'm going to make it rigid. And I'm going to make this end surface here, this back surface here. Okay, now if I want, I can rotate this around and make sure I get that back surface right here. And I'm going to make that into this back surface right there. Okay, and again, I made that rigid. Okay, and I'm pick apply. Okay, now I'm going to take and I'm going to insert this rod all the way to the back of there. Again, I'm going to rotate it. Okay, I'm going to make that rotational because I want this pin here to rotate. And I'm going to take this surface right here and I'm going to put it right against this surface right here so that it sits right in there like that, and it will be able to rotate on there. In reality, these balls rotate, but that's alright. I'm going to pick OK. Okay, now you see that I can rotate this around. Now what I want to do, I'm going to move this closer, is I need to align this point right there to this edge. See, which one's that going to be? Right here. And actually this one here to that one there. Alright, so I'm going to go into join and I'm going to make this rigid. Okay, and I'm going to take this guy right there. Okay, and I'm going to put that, let's see, right, do I want it there? I gotta make sure I get on the right plane too. Oh, not that one, let's go up this way. See what that looks like. Okay, and that looks like they're lining up perfectly. And I'll pick OK, and you can see that that fits there perfect. Alright, I'm going to take our little keyway here. Okay, I'm going to rotate it around a little bit. And I'm going to constrain. And I'm going to mate this surface here with this surface up here. Okay. And I'm going to pick OK, and let's see where that is. Okay, that's against there. Now I'm going to align or constrain the flush from here to here. Okay, and now that pin is sitting in there correctly. Okay, so now my keyway is good there. Okay, let's back up a little bit. Now what I want to do is I'm going to put this ball on the end of this guy. Okay, so I'm going to take and I'm going to free rotate him around till I find that hole. There's the hole. Okay, and I'm going to go to join, and I'm going to join this bottom part right there to this surface right there. Now it's going the wrong way, so I'm going to flip it. And I'm going to pick OK. Now that ball is attached to there. Now I'm going to take this thread into there. So I'll rotate around a little bit. And I'm going to join this surface here to that hole right there. Okay, and I will make that a rigid. And I'm going to pick OK. Alright, let's go back to here. Now I should be able to rotate this handle around. You can see the axle spinning there. Okay, now what I can do is I can automate that by using, under constraint, using this angle command here. And I'm going to set up an angle from the top plane here to the top there, and I'm going to set it to 0. Then I'm going to drive and change that angle. And as I change that angle, this has no option but to move. Alright, so I'm going to go here and I'm going to pick this surface here. Again, I'm at angle. Okay, and I'm going to pick a directed angle and pick that surface. and I pick that surface there. Now it sets it automatically to 0. So I pick OK. Now I can no longer spin this by hand. Okay, but if I find the last one that I just did, which was on the handle here, let's see, where is the handle? I call it a link. Okay, and here is the angle I just created. Now right click and I pick drive. Okay, notice if I move it, it moves a little bit. Okay, so here I can start with 0, and then it's going to move in 10 degree or move 10 degree. I'm going to move 360. Okay, and I pick go. Okay, and it looks like I didn't put my didn't finish my keyway. Okay, so let's spin this guy around. Okay, where's the keyway? Where the key? What I need to do is I'll take it and move it from that point to that point. Let's zoom up on that guy, and I'm going to constrain from this one here to this surface here. Okay, and that should lock that in. Okay, I'm going to go back to my angle here, and I'm going to drive it again, go 360. Okay, and now you can see it moving around. Okay, if I wanted to go faster, I can change the degrees. So if I move to 5, okay, it goes quite a bit faster. Okay, if you don't like that line there, okay, I've got that axis there, so I pick OK. Okay, there it's gone now. If I go here again, right click, drive. Okay, now it's gone. Now if I change this to 3600, for example, and drive it, okay, you can see it goes around, oh, probably about 10 times. So right there. And of course I can reverse it as well. Okay, so that's using a bunch of our commands. Okay, using our constraints and our joints, here is an example of one that I've done before, and it is a vise. Okay, I can then take and drive that. Okay, and I already set all this up. I'm not going to go through that. That's beyond what we can do. But you can see I can now take this and animate it. Not sure why those screws are green. Okay, I'll open up and stop and go back. You can see the screw thread moving there, the square thread. You can see the vise jaws moving as you turn the handle. Okay, so we can do all that. Now I'd like to take a look at taking one of the assemblies and putting it on a piece of paper. All right, let's take a look at our handle assembly and let's put it on a piece of paper. Okay, our assembly drawing, so I'm going to save it. I'll pick save as, and I'll call this handle assembly, and I'd saved it before, so I'll say yes. Okay, and that is fine. All right, now I'm going to go and open up our template. And my template is, oh, I went way too far. Here. Here's a size inches. And I'm going to put it there. Now I probably need a bigger piece than this, so I'm going to edit the sheet and I'll go to a B size at least. Let's try B first. Alright, now for the base, here is my part. Okay, I think I'll turn it this way and maybe put that view and that view, and then I could put an isometric somewhere if I wanted to. Okay, and I'll pick OK. I'll move these guys a little bit so they're not so crowded here. Alright, since this was the first view, I'll go into here and I'll display options, and I'll put the tangent, I'll put the interfaces where their interference edges, which are here, so I can see where that ball goes there. Okay, and that looks a lot better. And go into our isometric here and change this to so it looks nice and pretty. Okay, now I could take and I could make my, bill of materials and put my balloons. I might want to make some more room for that. Okay, all right, so that's what we could do to do that. Now I also want to show you how to make an exploded view. Create exploded views. We can make an exploded isometric view. So what I'm going to do is I'm going to go here to New. I'm going to go down here where it says Presentation. Create an exploded projection of an assembly. I think that's what I want. Pick Create. Okay, now it wants to know what I want. I'm going to go find wherever I put that. Hopefully it's this one. And I pick OK. Alright, and you'll see it gives me a couple things here. It gives me a timeline, and here is my parts. Now I can use the tweak command, okay, to move these parts. So for example, I could tweak and say pick this base. And you'll see I get arrows. I can move it up. I can move it over. And I can move it this way. Okay. Now I'm going to hit cancel because I don't want either one of those. I'm going to undo it back to where it was here. And I'll pick tweak, and I'm going to pick this guy, and I'm going to move him this way a little bit. Right about there. And I pick OK. Now I can pick the parts that way. If I can't see them, okay, I go into my parts here, and there I can see those and I can tweak them there. Alright, so I'm going to tweak this part here and move it that way a little bit. So I'm going to tweak this one and move him there. Pick OK. Now I'm going to move these guys out this way. Now I want to move this handle and hold the shift button down, this handle, the ball. Now I want to pick that little key in there. Now that is over here. Okay, that's the key connection. So hold the shift and I click on that. Okay, and I missed the shift, so I didn't get it. So I hold the shift button down. Now I pick this one, this one, this one, and this one. Okay, and then go into tweak, and now I can move all of those at once. Okay, so I want to move those right there. Okay, and then pick OK. Now I'm going to move everything except this one. So I go into tweak, and I can pick my key again, hold the shift button down, this one, and this one, and let's move them a little bit that way and pick OK. Okay, I'm going to take and tweak the key, move that guy right there. Okay, pick OK. I'm going to tweak this in here. Whoops, got to hold the shift button down. So let's cancel that. So I'm going to tweak this one here, hold the shift button, this one here. Okay, move them out a little bit, pick OK. Then finally I'm going to tweak just the ball here. Oops, I grabbed everything, so I'm just going to tweak the ball right there and put it right there, and then pick OK. Alright, so now you see that I have an exploded view here. Now down here I have a play button. If I click play, it puts it together, and you'll see that it starts moving them. Okay, I can record that if I want to. Now it'll put it all back together again. Okay, I hit the minus button, or the minus play, or go reverse order. Okay, and you'll see there goes the ball. And there goes the key onto the shaft. And there's my complete assembly. Okay, so let's say now that we want to take that exploded assembly and I want to put it on a piece of paper. What I have to go up here and I have to do is create a new snapshot. Okay, you'll see that it shows up here. Okay, now I'm going to go back to my drawing that I did here. Okay, and I'm going to pick a new sheet. Okay, and that's a B size again. Let's see how it looks. I'm going to go to base. Okay, and I have to save this. Okay, and I'm just going to call it the handle assembly. Okay, and it will automatically pick the view I did. If I have more than one, I can pick it here. Okay, now I might want to change that scale, make it a little bit bigger, like that. Pick OK. Again, I would probably take this one, put all those on, that's good. Oops, double click on it, make it look pretty. Okay, and there I have my exploded view. Now I could take this line here, for example, and all these lines go into them, highlight them, right click and go down to properties. Okay, right now these lines are by layer. I want to change those, and I want to make this a double dash chain. Okay, so that it has the correct line for these, and then I would go and do all of them. Okay, properties. Now I could do them, all at the same time just by using my shift button. So I could hold this one here, shift, that one, and I could do all of them. Go to properties. Okay, and change them to the double dash lines. Okay, and that's the lines that it should have. Now sometimes they don't show up here, but they will when you print it. Okay, then I would make again my bill of material and my balloons and fill out all the appropriate data. Alright, so that is using everything for creating assembly drawings.